So what we've talked about so far will enable you to successfully complete homework on page 84, where I'm assigning you 1 through 9 odd, 11 through 16 all, 19, 24, and 25 through 30 all. Now, I'm also adding to that homework worksheet called Instantaneous Rates. This is posted on the Google Classroom and also on the handouts page of the website. Hang on, I'm going to reorder. Cord issues. All right. This page is going to be on the Google Classroom. On this page, I'm asking you to do 3, 4, 6, and 8. So you only have to do 3, 4, 6, and 8. And me, I'm going to do number 1 and number 7. All right, so just show you how this goes. Now, this particular idea of finding the average rate of change over a specific interval, finding the average rate of change over an interval that involves an h that we're going to take a limit of, finding that limit as h approaches 0, and then stating the instantaneous rate of change using correct units. These are really essential ideas from calculus. This will be on the evaluation. This is in fact relates to section 2.4 in your book, which is called rates of change. And we've already done this in our introductory limit videos. So what I'm going to do is just go through a couple more examples, because this is the part, what I'm going to show you is the part you have to be able to reproduce on your own. If I recall correctly on the assessment that I'm going to give you, I think I asked you to come up with your own instantaneous rate problem and solve it. I think that's what I did. Anyway, so here's what we're doing. Number 1 from this worksheet, I guess I already put number 1 there, f of x equals 5x squared. All right, so we're asked to find A, the average rate of change over the interval 3, 4. Okay, so the average rate of change over 3, 4. This is an important word. We're starting with average rate of change. We end up with instantaneous rate of change. That's what we're doing here. All right, so for average rate of change, so what you want to know for the average rate of change of a function is always f of b minus f of a over b minus a. It's just the slope formula, y2 minus y1 over x2 minus x1. All right, so what we need to do for the average rate of change, so sometimes we call it r_av, like that, like a subscript av, equals, so one nice way to start writing this is I'm going to go, it's like f of 4 minus f of 3 over 4 minus 3, just so people who's looking at it can see where it's coming from. And then I'm going to say what those things are. I'm using 5x squared, so that's 5 times 4 squared minus 5 times 3 squared. And I can say the denominator's 1, and then I can start dropping the denominator. So here I have 80 minus 45, is that what it is? So it's 35, equals 35. Okay. I'm not including units. If I could say, if this was like meters per second, I go meters per second here. But this problem has no units in it. So there are no units to talk about. It's really like y units per x unit. But we don't have to worry about that because there's no unit specified. Part B says find the average rate of change over the interval 3 plus h. So over the interval 3 plus h. So especially people whose work is not terribly organized, look at how I'm organizing this. I personally am not an intrinsically organized person. I force myself to be organized so that other people can understand me. So this is the average rate now is going to be f of 3 plus h minus f of 3 over 3 plus h minus 3. So I'm being explicit about where everything comes from before I start simplifying it. All right, then I can say, all right, this is equal to 5 times 3 plus h squared minus 5 times 3 squared. And then the denominator, now I can simplify and just say I just have h. All right, and then this equals, so look, in these kind of problems, especially assuming x is not linear, which is rarely going to be, you're always going to have to square out or maybe cube out or fourth power out a binomial. That requires you to understand binomial squares and what's his name's Pythagoras, not Pythagoras, the other P guy, Pascal's triangle. If you don't understand those things, send me an email and I'll make a little video about it. All right, anyway, you should know that this is 5 times 9 plus 6h plus h squared. And over here, we already figured out that was 45, so we can just say 45. keep the denominator of h. See, another thing that sometimes people do in their homework is that, like, they'll just work out this part and then stick the h back in the end. Write the entire expression every time. That will help keep you from making mistakes, and it will make it easier for people who have to read it. Distributing the 5, 45 plus 30h plus 5h squared minus 45 over h. In these rates of change problems, when you're finding the instantaneous rate of change of a polynomial, this will always happen. We will be able to take advantage of that pattern, things that always happen, in order to very quickly get these rate of change without doing the whole limit process. But we have to know where everything comes from, so we're going to read like this. And then because we are going to be ultimately interested in where h is 0, we're not going to reduce the h's yet. We're going to save that for part C when we do the limit. All right, so part C where we do the limit. All right, part C says, find the limit as h approaches 0 of the average rate in part B. All right, here's my average rate in part B. I want the limit as h approaches 0. So I want the limit as h approaches 0 of 30h plus 5h squared over h, 30h plus 5h squared over h, okay? Now, especially people who, in your homework, if I made a comment about keeping the limit statement on until you evaluate, make sure you follow what I'm doing with the limit, because when I reduce this, it has to still be a limit. I write limit as h approaches 0. I don't just put h approaches 0. Limit. It's not hard to write 3 letters. Reduce this, 30 plus 5h. I will often be lazy and leave it like this. It's actually quite nice to put it in parentheses, otherwise, how do I know what part's included in it? The next step, I'm evaluating the limit by substitution. When I'm substituting that 0 in for the h, that's when I drop the limit, because that's when I'm doing the limit. So it's not a limit anymore. Notice how I wrote the whole expression out with the 0 in there. Now I'm just going to say that equals 30. All right, so that's my part C. The limit as h approaches 0. Now, part D, people often get confused by, because it says, state the instantaneous rate of change. Okay, it doesn't say calculate or find. You already found things. State it. State the rate of change. You already found it. Where appropriate, include correct units and interpret in the context of the problem. This problem has no context. We will next see problems with context, so we will interpret in the context of the problem. For now, it's not appropriate to do these things, so we're just going to state the instantaneous rate of change. We're going to state it like this. The instantaneous rate of change of f at x equals 3, because all of these are happening at 3. We're letting the h approach 0. We're finding the instantaneous rate of change at 3 whatevers every single time, because we're following this template. So we will always be finding, we don't want to just say the instantaneous rate of change is blah, okay, because the instantaneous rate of change is constantly changing. The instantaneous rate of change depends on what the x is. The instantaneous rate of change of f at x equals 3 is 30. That's what you want to write for your part D, and this value that you calculated as the limit, you're showing that you understand that that is the instantaneous rate of change. Okay, so the first thing that you calculated was an average rate of change, was 35. It requires an interval, 2 x values or t values. What you ended up with is an instantaneous rate of change, which only requires 1 x value, and it's 30. It's different from the average rate of change, right, which was 35. Okay, we'll do one more next.